part of our applications of differentiation deals with concavity. Now remember, a concave mirror is one that just kind of goes inside of itself. And so you see these at fun houses, you put your face up there and it distorts your face. This is kind of the same thing, except it's not going to distort your face. Maybe it will distort your face when you're doing the math on it, but it's not supposed to distort your face like a reflection. So the definition is let f be differentiable in an open interval I. The graph of f is concave upward on I if the derivative of the function is increasing on the interval, and concave downward if the derivative or slope is decreasing on the interval. So it's a matter of examining if your slopes are increasing, your slopes are decreasing. Okay? And so how do you do that? Well, to test for it, we look at something called a second derivative. So it's the derivative of the first derivative that we call the second derivative. So you're going to be given a function, you're going to find the first derivative of it, and then you're going to turn around and find the second derivative, which is the derivative of that first derivative. And if that turns out to be positive, it is concave upward. And if it's downward, it's concave. It's downward if the concave, if the double prime, the second derivative is negative. And if it's in between, then that means it's neither one. And that's something we deal with in the section after we're done with this. So we're just testing to see if your curve is going up or down, or up in part and down in part. It depends upon what the equation is. So we'll start with problem number 1 on page 195. So you do indeed take the first derivative. Now, before we get too far into this, if you want to graph this, it's probably not a bad idea to do that so you can see what's going to happen here, what you should get. These things will actually tell you what you should get. This is a problem because of the fact there's no square here, but there is a square here. And so you know it's going to go up or it's going to go down because you have a singular y and a squared x. And anyway, you take the derivative of that, you get 2x minus 1, that drops out. And then we take the second derivative, so it's the derivative of the first derivative, which is just 2. The fact that that's positive means that it's going to be strictly a concave upward graph for your problem. So this is concave up. Okay, let's take a look at number 3 on page 195. This is a little bit more of a challenge. There are all kinds of things going on here, so we're going to take the first derivative of that. And this is going to give us, I'm going to use the law, the quotient rule for this. So this will be x squared plus 12 times the derivative of 24, well, the derivative of 24 is 0. That just basically cancels out. Minus, because it's quotients. Now we take 24 and take the derivative of x squared plus 12, and the derivative of x squared is 2x. The derivative of 12 is 0, so this is what we get here. Over, and now we're going to square the denominator, x squared plus 12 squared. So when we get this all resolved here, we get negative 48x over x squared plus 12 quantity squared. Okay? Now that's not too bad, but boy, the next step, this is a doozy. And this is where I really caution you in a number of areas. The main one is to go slowly. Don't try to blast through it. Shut off the music, shut off the TV, and focus on this because it's going to be a lot of little things that can be missed if you're not paying attention. So, we're going to do the same thing here. We're going to take the quotient rule again. This is x squared plus 12 quantity squared times the derivative of negative 48x, which we know is negative 48, minus, and now we're going to take negative 48x times the derivative of x squared plus 12 quantity squared. Well, the first thing we do is we take this 2 down and subtract it on this. We're using x squared plus 12 to the first power, this x squared plus 12. and then we derive what's inside of it using the chain rule, and we get 2x plus 12 drops out. And this is all over the square of this. And the square of a square is the fourth power. So this is x squared plus 12 taken to the fourth power. Okay? Now, this is the point where I'm going to tell you that it'll be, what happens next is really up to the professor that you have when you take this class in college. There's some things to look for that'll help you get what he is or she is thinking of. And so you need to kind of look for these little tricks of the trade, if you will, to simplify this as much as you can. You notice here that we have x squared plus 12 down here, just fourth power, but it's an x squared plus 12. We've got an x squared plus 12 here, x squared plus 12 here. So we got something in common. Looks like we're going to be able to cancel something out. So we're going to deal with everything else. I'm going to move this negative 48 in front. So this becomes negative 48 times x squared plus 12 squared. Then minus the negative becomes plus positive. 48 times 2 is 96 times 2 is 192. X times x is x squared times x squared plus 12 all over x squared plus 12 to the fourth power. Now I'm going to, the fact that we have at least one x squared plus 12 in each of these two terms means I'm going to factor that out. So this is going to be x squared plus 12 times, so I'm taking x squared plus 12 out of this term right here, that leaves me negative 48 times x squared plus 12. And then I take this x squared plus 12 out, that leaves this plus 192x squared all over x squared plus 12 to the fourth power. Okay, looks like we're going uphill. All right. Now, this will cancel out one of these right here to leave this cube. And at this point right now I'm going to go ahead and multiply negative 40 by these two right here. Then gives me negative 48x squared minus, and 48 times 12 comes out to be 576 plus 192x squared over x squared plus 12 to the third power. Now I'm going to combine these two x squares, and it gives me 144 x squared over, minus 576, that's kind of important, over x squared plus 12 cubed. Okay? Now, at this point, you could stop with calculators now, that's fine. Most of this stuff was all being learned and discovered before calculators. In fact, your professor, who might be within 10 to 15 years of age with me, might have been taught by their compadres or their teachers to factor this out. My personal feeling is it's fine the way it is because the calculators allow you to do this. My concern is, who are you going to get for a professor when you get to this point? So I'm just going to go ahead and simplify this so you can see it happen. My concern is that I'm not going to worry about it with you, but you may want to worry about it, so you're not going to keep attempting to do this. So this becomes alpha double prime x, which I've been ignoring all the way here. It's going to equal to, and there's a factor of 144 out of both of these. Why would you know that? You know, unless you like math like I do, you probably wouldn't know that. X squared minus 4 over x squared plus 12 quantity cubed. This actually kind of makes it easy to figure out, but you don't have to do that unless your professor tells you to. So this is what we're going to use, and we're going to set that equal to 0 to determine the points at which it changes from negative to positive or positive to negative for the f double prime, which is concave up, concave down, or concave down, or concave up. Well, you don't have to worry about these right here because it's never going to equal 0. You just multiply both sides by that, cancels that out. 144, divide both sides by 144, that cancels that out. That means then that x equals plus or minus 2. Or you say x equals negative 2, or and x equals positive 2. So we have both values. So now we do that interval thing that we did with the previous section. Only now we're looking for concavity instead of direction of slope. So we have two intervals. I1, well actually three intervals because we've got 2 points here. So I1 is going to be from infinity to negative 2. I2 is going to be from negative 2 to positive 2. Oh, goodness. And the third interval is going to be from 2, and actually a negative infinity, by the way, because we're going from the left hand, now to the right hand, which is positive infinity. And then we're going to test with a point for each that's within this, and then I'm going to use negative 3 for this one. I'm going to use 0 for this one because it's really easy to do in my head if I want to do that. And this is going to be positive 3 right here. Okay? So, next thing you're going to do is to plug in for your double prime equation, which I'm going to use this one here, the 144, blah, blah, blah. You can use that. It doesn't make any difference, like I said. So this is going to be equal to 144 times negative 3 squared minus 4 over negative 3 squared plus 12 1 cubed. And when I do that, that gives me 0.0777. That's a positive. So that means that this is concave up. Do the same thing with 0 here. So I'm going to use 0 here. And I'm going to put 0 right here and 0 right here. And then I'm going to calculate that. And when I do, I get negative 0.333, which means it's going to be concave down. And for this one right here, I'm going to use positive 3 because it's between 2 and infinity. And I hate this board. I really hate this board. I can't tell you how much I hate this board. So, I'm going to put a 3 here instead of a negative 3, or 0 and 3 here. And when I do that, my value is positive 0.0777, which again, like this, concave up. Which makes sense because the 7s are up. 7 up, I'm not that thirsty. Okay, we'll stop there and move on to the next problem.